Okay guys, so we're just reviewing the year 8 paper, so I'm just going to do every single question, so if you don't need it, forward it. If you do need it, obviously keep watching it. If you want to watch it again, rewind. But we just need to review the paper. So I'm just going to put the working out here. I've also got the paper shown on my wonderful computer screen, so you can see the answers next to the working because I don't have a copy, so I can't do it on the copy. So let's just get started. Okay, so it says round 8.136 to 1 decimal place, so 8.136 to 1 dp. Okay, that's my first decimal place. They've only asked 1 dp. I'm just going to stick a line there. 3 does not make the 1 go up, so my answer is 8.1. Nice and easy. They then say 15.723 to 2 significant figures. Okay, so then I'm looking at significant figures, which is my first non-zero value. So that's my first non-zero value. That's the first significant figure, but they've asked me for the second one. That's my second significant figure. Now I'm going to stick that line there. And then you look at the 7 and you say, does the 7 make the 5 go up or does it stay the same? It makes it go up. So then my answer would be 16. Next one, where it says choose the most appropriate unit to measure the height of a building. Okay, so this one should be pretty logical. Meters you can use for buildings, people, edge of a garden, fence, those kind of things. Millimeters would be very small. This would be if I'm like measuring something incredibly small. So if I was talking about, oh, what's the width of your eraser? That would be millimeters. If I was saying, oh, what's the thickness of this pencil? That would be millimeters. Okay, you don't just use millimeters for like the side of a building. Okay, and then you also have kilometers, which is quite a big distance. So obviously, if any of you have ever been on the roads and seen road signs, you usually see like distances. So they'll say like Dead Sea, and they'll tell you how many kilometers away you are from the Dead Sea. So kilometers will be used for very big distances, millimeters very small, and then your meters would be the only one that fits with buildings. It's the one that you measure people and doors and gardens and everything with. Okay, choose the most appropriate unit to measure the weight of an apple. Okay, so kilograms. When I look at a kilogram, if you take a 1 litre bottle of water, that would be 1 kilogram of water. I would not measure an apple by 1 kilogram of water. I would be measuring it by a smaller unit. So then I would have chosen the grams for the apple. I wouldn't have chosen kilograms. So although I know if you get quite a big bag of apples, they usually sell them by the kilo, but that's because it's a big bag. If it was just one, they usually go by grams. And then last but not least, it says change 3.5 litres to millilitres. So obviously, milli means 1,000. So if I have 1,000 millilitres, that's 1 litre. If I have 1,000 milligrams, that is 1 gram. If I have 1,000 millimeters, that is 1 meter. Okay, so in this case, we've got 3.5 litres. I'm going to times that by 1,000, and I'm going to get 3,500 milliliters. Sorry. Next. Okay, it's asking about the inequalities. So make sure you just expand the brackets. Once you've expanded the bracket, you would have, for this one, it's 3x, and that will be plus 6. So that's 3x plus 6. The other bracket that you need to open for this one, 3x plus 60. So it's 3x plus 60. So now I can just pop them into these inequalities. So I know this one becomes a 3x plus 6. I know that is more than 3x plus 5. Okay, and then I've got this one, and I've got this one. This is definitely bigger than this, so I'm going to stick it the other way. Right? Hopefully that makes sense. A bag contains 15 red and 25 green counters. Write the ratio from red to green. Okay, so we've got ratio red to green. They're asking for red to green. Just write it down. It's much easier. It makes it much easier when you're doing this. I have seen questions where they try and confuse you, and they would have put green to red, and they would have just confused you that way. So it's not always the way that it's written down in a question. So just make a habit of writing red to green. Okay, so that is 15 to 25. They do ask you for simplest forms. So now you need to say, do they have a common factor? Can I divide them? Yes, they do. Their common factor is 5. So then it becomes 3 to 5. Then you look at 3 to 5 and you go, did they have a common factor? My only common factor for 3 to 5 is 1. So that is my simplest form. I should not expect decimals at any point in time during this whole process. Okay, then it says one counter is taken at random out of the bag. What is the probability that the counter is red? So there are a couple of different ways of doing this. Otherwise, you could look at this grouping and you could say, well, this is red, this is red, this is red. And then you would say, well, this is green, this is green, this is green, this is green. And, sorry, I'm just going to pause. Okay, so where is it? Dun, dun, dun. Well, probably count as red. Yes, okay. So we've got 3 groups of this, 5 groups of that. So my probability of this being red is 3 out of 8. So I'd say 3 divided by 8 is my probability. Okay, alternatively, you could have looked at the actual original and you would have said, well, there are 15 red and I've got 15 red and 25 green. So you would have said, well, 15 counters over 40 counters. That does simplify to 3 over 8. It's the same answer either which way you could have done it. Okay, the last question is actually a bit of a trick question. This question only tells you about red and green. It doesn't tell you about any white ones. So when it said, calculate the probability of the white ones, you should have gone, oh, there are no white ones. What's the probability of getting a white then? 0. Because there's no white ones. I know, it sounds simple, because it is. So sorry. Anyway, so, our wonderful indices. So you should remember from indices, if I have a multiplication power, what do? I'm hoping that all of you are randomly talking in the video and saying, well, you just add the powers. Yeah, that is what you do. Okay, so this is a to the power of 3. This is a to the power of 6. Altogether, I have a to the power of 9. Okay, and so the multiplication law is where you actually just add the powers together. Okay, and you would have done the same with division, except it would have been the opposite. So if I have b to the power of 6 all over b to the power of 3 underneath, you then look at those and go, well, I can cancel off that one, I can cancel off that one, I can cancel off that one. What am I left with? I'm left with this. So altogether, this would have been b to the power of 6 and b to the power of 3. But after all of this, I'm just left with these 3, which is then b to the power of 3. So that would be your answer. And then the law that you should know is where you, when you're dividing, you just subtract the powers. Okay, so hopefully that was nice and quick. Okay, next thing we need to look at technical terms. A lot of you, I think, need to revise technical terms because the only one that you seem to kind of recognize is the equations. You don't seem to recognize the other things. So I'm going to say you need to make sure that you know what a term is, you know what an expression is, you know what a variable is, you know what a constant is, you know what an identity is, and you know what a formula is. Okay, so, oh, why did I put it in such a way? A variable is anything that's always changing. So that could be y, that could be x, that could be alpha, that could be theta. Or if you're listening to Kasai, he started using Arabic letters, which is perfectly fine. He just made it a variable. It was just something that kept changing. The only reason why I have these is because the Greeks did a lot of maths, and so we use part of the Greek alphabet. It's kind of logical. Okay, a constant is anything that is fixed. It is a fixed value, okay? So most of the time, constants are just numbers, okay? So even when you're trying to find out what the gradient of a straight line is, you are literally trying to find out what a fixed number is, okay? So when you were using your y equals mx plus c when we were doing the straight line, your m would have been the fixed value because your gradient of a straight line is fixed, and then the c, the y-intercept, would have been a fixed value as well. So that would be called a constant, okay? But most of the time, it's usually when you refer to numbers. A term is anything that is a variable or a constant, okay? So a term is a variable or a constant, whichever one's out of those it is. I'm just putting VC because I don't like writing a lot. Okay, an expression is a collection of terms. This could be one term by itself, or it could be a number of terms. So I could just say x by itself and say my expression is x. That would work. Okay, or I could say it's x plus 3. Or I could make it really complicated and just say, oh, it's 3x plus 2y squared, take away 5k n. Just a whole bunch of terms. It's just a collection of terms. Okay. Oh, I didn't put equation down. I'm so silly. Why did I not put equation down? Okay, equation and formula. Quite a lot of people think equations is all just about an equal sign. Okay, so if I put this in, x plus 3 equals 4, that's an equation. But if I put e equals mc squared, that's not an equation. That's a formula. Okay, so an equation is where I can find a fixed value. If there's only one variable, there's an equal sign. I know that x is true in this equation only for the value of 1. That is why it's an equation, because it's true for just one value, or maybe 2 values. If it was quadratic, obviously 2 values, cubic, 3 values, so on and so forth. But for this one, it's only true for one value of x. It's not true for all values of x, and thus it is an equation, okay? For a formula, I have more than one variable. So e varies, and so would m. So because those two vary, that becomes a formula. Okay, an identity is where it's true in all cases. So if I said 3a plus 3b, that is identical to me saying a plus b. Regardless of which variable I change, they will both change and it will always be true in all cases. Okay, so that's why it's an identity. And you use, the really easy way to see an identity is you see the equivalent sign. That's super equals that you guys were talking about. That equivalent sign, that is what gives you an identity, okay? You need to make sure you remember these, okay? And because those were two really quite easy marks that quite a few of you lost out on, because you kind of put equation and then a lot of you just guessed expression. There's an equivalent sign in there. Why would you put an expression? Expression doesn't have any kind of sign. It's just a bunch of terms. Okay, so there's that. So in terms of that question, 10 equals 3x take away 7. It's an example of, they don't actually tell you about a formula in that list, so automatically you could have said it was an equation just by means of deduction, or you would say there's only one variable, so it must be an equation. Okay, and then for the next one, you've got 3 open bracket x plus 2 close bracket is equivalent to 3x plus 6. Yes, it is. If I expanded those brackets, then the left-hand side would become 3x plus 6, and so the left-hand side, the right-hand side would equate to each other. That's an identity. Okay, moving on to the next thing, we've got 3x equals 285. You would have solved this in one of two ways. I don't mind which way you would have done it. If you had done it pictorially through our wonderful bar models, you would have had 285, and then I've got 3x equals 285, 1x is 95. Okay, or you would have used an algebraic method, and you would have got it that way. You're saying dividing it by 3. I don't mind which way you use. Obviously, there's no point in using both of them. That's a bit of a waste of time. But whichever one you use, they're both valid methods. Okay, then you've got the inequality. 4y plus that equals 15. Okay, looking at the algebraic method first, it works perfectly fine. You've got 4y is more than 12. Then divide both sides by 4. You then get y is more than 3. I have not changed this to an equals at all. I do not expect to change it to an equals at all. Yes, I've used the same techniques that I use for equations, but I have not changed this to an equal sign. So I'm not expecting anyone else to change it to an equal sign either. Okay, if you were looking at it pictorially, you could still do the same thing. Oops. 1, 2, 3, 4. So that's y, 3. So if that's 15, this must be 12. If this is 12, then you've got 4y is more than 12. Y is more than 3. I've still got the inequality. I don't have an equal sign. A lot of you started putting equal signs on there. Please don't do that. They're not the same thing. They use the same techniques, but they're not the same thing. One is saying, oh, it is more than this value. So I'm saying y is more than 3. I'm not saying it's equal to 3. It's never equal to 3 in this inequality. It's always more than 3, okay? So always be aware of that. It might seem like quite a minor detail, but it's an important detail. Okay, so next, super easy. So we've got 23%. 23% is the same as me writing 0.23. 0.23 times 680. I think I remember, but I'm not going to guess it. It's 154, isn't it? 680? No, it's 156. Okay, 156.4. Okay, that's my answer, but because I'm talking about money, would I leave it like this? No, because no one will be able to tell whether I'm talking about 4 pence or 40. So I need to make it clear, put the second decimal point in, okay? Sorry, second decimal place in. That's money. Money usually has 2 to 3 decimal places. When you are talking about pounds, it will always be 2 decimal places, okay? So if you figure out whichever currency it is, obviously find out what the currency is. So if you did go to Carrefour, obviously you would see those stickers, and they usually go to 3 decimal places. Okay, but if you ever look at the British currency, it's always 2 decimal places. It's not 1 decimal place. Please don't do that, because when people see that, they'll be like, well, you haven't defined what it is, and they could easily dock you a mark, which they did in this case. Okay, so ratio of boys to girls in a class is 2 to 3. So boys to girls is 2 to 3. Yes, I will always write stuff like this down. It helps me focus my mind. Okay, so what fraction of the class are girls? Okay, this is girls. So that means I have 3 girls out of a group of 5. Okay, if you did want to look at it this way, you would say, well, there's 2 groups to 3 groups. This is my girls, this is my boys. I've got 3 girls, but I've got 5 altogether. So that's the fraction of the class that are the girls, okay? And then you have percentage of boys. You could look at the boys in the same fashion. So this is me talking about girls, but they're talking about percentages, but I can still work with what I have. So this is boys, this is girls. I've got 2 out of 5, so boys is 2 out of 5. This is the same as me saying 0.4, which is the same as 40%. They've asked for percentage. Please give it in a percentage format. Okay, and last but not least, they are saying 18 girls. Okay, if there are 18 girls, I'm still using this bar model, because this bar model is like amazing. That's 6, 6, 6. If these are all 6, that means these are 6 as well. Altogether, I've got 30 students. Okay, they're not asking about the number of boys. They're asking how many students altogether. I know a few of you calculated the number of boys, but didn't add them to the number of girls, and so you lost a mark because you didn't actually answer the question. You need to ensure you always answer the question. Okay, so Summer. Okay, Summer sat 2 maths tests. Oh, why did I do that? I still have space. I need to use this paper up. Okay, sorry. So test 1 is 72%. So I've already got the percentage, so I'm not worried because it says which has the higher percentage. Got the percentage, not worried about that one. Test 2 is 14 out of 19. Okay, so 14 over 19 is 0.73, I think it was 736, but I cannot remember. Okay, 736842, dot, dot, dot. I'm just going to put loads of dots. There is a lot of stuff there. Okay, this is the same as 73.68%. Some of you wrote it as 73.7%. I would have accepted that. Or if you had written 74%, I would have accepted that as well. You needed to make sure you rounded it correctly. Quite a few of you put 73%. That's not correct. It's 74. Okay, and then once I've got that, I can just say 74 is more than 72. Therefore, test 2 has a higher percentage. Okay, they don't actually ask for this particular statement within the question. I've just got a habit of writing down statements because especially when you go up in the years, they will start asking you for statements. So this is something that you could look forward to, potentially. Okay, so nth term of a sequence. Sequence is super, super easy, guys. Okay, so it says nth term of a sequence is 2n plus 1. They're asking for the 10th term. When they ask about the 10th term, n equals, surprise, surprise, 10. So then you say 2 times 10 plus 1. And I'm sure all of you can say that in the funny fashion that some people say 21 because it's too hard to say 21 in a normal voice. Okay, also, looking at this, some of you may recognize just by this, if you have the sequence, it's 3, 5, 7, 9. Okay, you may recognize that I'm adding 2 each time, and this 2 corresponds to this 2 here. Okay, when you're doing sequences, you should be remembering that the number that corresponds to the n is the jump up or the jump down each time. So when I've got the second part of this question, it says 39. I know I'm adding 2 to go that way. I know I'm taking away 2 to go that way. So this side should be 41 and this side should be 37. Okay? And then they give you a completely different sequence. So don't start referring to all this up here because they're not talking about that anymore. They've given you a completely different sequence. And then they're saying 10th term. It's the same technique that I used up here. Just going to say n equals, oh look, it's the 10th term, so it must equal 10. So I'm going to say n squared, so instead of n squared, I've got 10 squared. Instead of 7n, I've got 7 times 10. Okay, 10 squared is 100, and then I'm adding 70, which gives you 170. That is your answer. Next one, standard form. You guys spent a lot of time on this, and you're pretty much experts on it, and then you did this, and then I was like, what happened? Okay, so you've got 1.3 times 10 to the power of 3. Okay, this is the same as me putting 1.3 times 1,000, because 10 to the power of 3, you've got 1, 3 zeros, which is 1,300. A couple of you actually wrote this, but then wrote 13,000. Let's just leave that pause. Okay, and then for the next one, I've got this. So I know the first number needs to be between 1 and 10. So I'm going to say, well, 5 point. Okay, so I've got 5.6 times 0.0001. Okay, which then becomes 5.6 times 10 to the power of -4. Obviously, if it's if it's bigger than 0 or less than 1, then obviously it's the negative power, and if it's more than 1, then it's that positive power. Okay, next question. Factorize. 25 plus 10p. Okay, very similar to what we were doing for one of the questions near the beginning. Do I have any common factors? Yes, what's my common factor? 5. Okay, but this time, instead of just getting rid of the 5 is going to be outside, while I go 25 divided by 5 is 5. 10 divided by 5 is 2, and then obviously you carry that p down. Yeah, and if you can't do this technique, obviously you've already got the grid technique, which quite a few of you are also using, and we're saying what factor is common? Got the 5. So 5 times something is 25, which is 5. 5 times something is 10p, which is 2p. And then you've got exactly the same thing. So you've got 5 and, 5 plus 2p there, which is exactly the same. Okay, and then it says expand and simplify, which is super easy to do. This is 6m, this is 3. So I'm saying 6m plus 3 plus 5m, and now I just need to simplify, i.e. collect the terms. These are the two that have an m. This doesn't have an m, so I'm just going to put 11m plus 3. Okay, next question. So we've got the point 310 lies on the line, y equals 3x plus 1. Okay, so what's important is you need to remember coordinates. If you cannot remember the order, just go through the alphabet in your head. Okay, what comes first in the alphabet? X or Y? X. So X goes first, Y comes after. Okay, and then it says it lies on this line. This is just like the sequences. Okay, so you would say this is a 5, this is a I don't know. What do I find out? This is my x. So that means I need to find out what this is. So the way to find out what this is I use this equation that they've given me. I need to find out what my y coordinate is. They've told me y equals 3 times x plus 1. So that'll be 3 times 5 plus 1, which is 16. Okay, so that's nice and easy. It's a 16. This is... I don't know the answer, even though I kind of wrote it down. Okay, so I don't know the answer, and then it's a 1. Okay, but in this case, I'm saying y equals this. So if you do want to do your bar model, you can do it via bar model. I've got x, 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 1. Okay, so I'm saying altogether it's 1. So what is this 3x? That 1, take away that 1. This equals 0. So this must be 0. Yeah? If you'd done it the other way, the algebraic way, you would have had 3x plus 1 equals 1. So 3x equals 0. Sorry, take away 1 from both sides. Divide by 3. Just don't know why you have to divide by 3, but just in case you want that extra step, it's there. Okay, the 310 is not actually important to this part of the question. It's important to the next part, but it's not important to this part. Sometimes they do give you information that you may not necessarily need in that question. Just be aware of it. Okay, so for the next part of the question, it says 310. It goes, which of these other lines lie on this point, 310? Okay, they haven't given you anything too complicated. They've just given you a bunch of horizontal and vertical lines. So, nice and easy, you just go, which coordinate is this? It's x. Okay, so x equals 3. Which coordinate is this? It's y. Okay, so y equals 10. There are your two answers. Okay, don't look at one answer and say, this is my answer, and then leave it. Just because it's a 1-mark question doesn't mean there's one answer. It does say circle your answers. So it kind of gave you a hint that there was more than one answer. Quite a few of you only circled one answer. You should have circled 2. Okay, so next. Ooh, like this question. This question's amazing. So you got 68 degrees of this, and I can only lean it if it's between 70 and 75. Otherwise, I'm not climbing on that ladder because it wouldn't be safe for me to climb on that ladder. So Bobby tells me increase by 10% and it will work. Okay, so this is what I need to do. Increase by 10%. Is Bobby right? Okay, so I've got my 68 degrees, which is my original, and then I'm going to add 10% of 68 degrees. I need to find out what that value is. But first of all, I need to find out what 10% of 68 degrees is. There are several different ways. Some of you might have said 0.1 times 68, which is 6.8. You might have gone, oh, to find out 10%, you divide by 10. There were a variety of ways that you could have used. I'm just going to use this one because multipliers are easy for me. Okay, so I'm going to say 68 plus 6.8 is 74.8. Is this within these parameters that they've given me? Yes. Okay, so the question does actually say, is Bobby right? You must say yes. That's important. That's you making your statement, because the question wasn't find out 10%, add them together. That's not the question. The question is Bobby right? So when you say increase your angle by 10%, your ladder will be safe to climb, you're answering that question, okay? Sometimes I think a lot of you do the really hard work and you forget to make that really easy statement at the end. If you were a technical person speaking to a person that didn't have as much technical ability as you, they wouldn't ask you a question, you just run through the maths with them. They would ask you a question, you would do the math, then you would give this answer to them. And then if they ask for further explanation, that's when you show them the maths, okay? But make sure you actually answer the question. Okay, and last but not least, okay, I'm just going to do it here because I'm going to waste an entire piece of paper on this. So you have a MAD, so I've got 4n squared, and then I've got open bracket 4n squared. Okay, so a MAD goes, n equals 3, they equal each other, right? He's basically, that's what he's saying. And then Jenny is saying, n equals 3, they do not equal each other. Okay, so all you need to do is see who's right, who's wrong. So otherwise, Ahmad's going to be right, or he's going to be wrong. If he's wrong, Jenny's right. If Jenny's right, he's wrong. Okay, so I don't need to go through any algebraic proof or anything for this. They've already given me what value I need to work with, so just work with that value. They've both got exactly the same value, so I only have to work it out once. I don't have to work it out twice. Okay, so when n equals 3, I've got 4n squared, that is 4 times 3 squared, which is 4 times 9, which is 36. This one is 4n in brackets squared, which is 4 times 3 squared, which is 12 squared, which is 144. Okay, these two do not equal each other. So Jenny is right. Okay, it does say show your working. If you just put Jenny and no working, you get nothing. But you need to show that you put the work in. Okay, so if you'd done this work, I'm just saying it doesn't equal each other. Jenny's right. Nice and easy. Okay? I think everyone could have done that. I think a lot of people looked at that and were a little bit stuck, but quite a lot of you could have done that. But if you just make sure you go through on this, and that should be it. Okay, take care. Where am I going to do this?